Hi everyone, welcome to lesson 5 of our exponents and logs units. Today we're going to be talking about graphs and transformations of the logarithmic function. So right away here we have example 1. It says sketch the function y equals 2 of x and its inverse on the same axes, so basically on the same graph here. Identify the characteristics of each off to the side. So my equation is going to always start off at 0, 1. In this case here, if our base is 2, our first one here is 1 x1, y2, x2, y4, x3, y8 should be right up here. And of course, if we went to the negatives, x negative 1, we're at a half, and x negative 2, we're at a quarter. I'm going to try my best to sketch my line on here. My line's basically going to try to run above the x-axis there. I kind of dipped below, but it should be really above the x-axis because we have a horizontal asymptote. And there we go. There's my y equals 2 of x function. Let's state our domain range, x-intercept, y-intercept, and equation of asymptote here. So our domain, of course, and I'm going to add on arrowheads there. As far left as negative infinity, as far right as positive infinity. So we're going to write negative infinity to positive infinity right there. Range, the lowest we're going to go is 0, and the highest is going to be positive infinity. Rounded bracket here on infinity, but over here I'm also going to put a rounded bracket because we're never going to cross our x-axis. That also means we have a horizontal asymptote at y equals 0. X and y intercepts, we don't have any x-intercepts, so I'm going to write down none. And y-intercepts, we do have one, and that coordinate is 0, 1. If I am trying to find the inverse of everything, I just take all their coordinates and switch all the x's and y's around. So if my original was x comma y, my inverse will now be y comma x. So on this original coordinate was 0, 1, now I'm at 1, 0. This one here was at 2, 1, so I'm at 1. I'm at 1, oh wait, this is 1, 2, so it's going to be 2, 1. There we go. Here we're at 2, 4, so I'm looking for 2. And of course here it was 3, 8, so I'm looking for 8. 8 and 3, so I'll go 2, 3, 4, 5, 6, 7, 8, 8 and 3. Right around there, there we go. This one here was at negative 1 and a positive a half, so I'm at positive a half, negative 1. Here was negative 2 and a quarter, so now I'm at a quarter and negative 2. So I'm just going to run down this y-axis here. Looks like we won't be crossing that y-axis. We're going up and we're going to try our best to curve through as many of these coordinates as possible. And there we go. Arrowhead, arrowhead, and so let's write down our equation. So this was the inverse graph, so this is really x equals 2y, so that's inverse, so we're just switching all our x's and y's around. So I'm going to write this one here as x equals 2 exponent y, but really we never have an exponent y. We want to rewrite that, and the way we rewrite that is to use logarithms. So it's going to be written as y equals log base 2 of x. There we go. So from here, let's state our domain range. Domain here, as far left as we can go, was 0, as far right as positive infinity. Our range as low as negative infinity to positive infinity. Do we have an x-intercept? Yes, we do. This time it's at 1, 0. Down here, we don't have any y-intercepts, so I'm going to write down none. And here, equation of an asymptote. We do have an asymptote. It's a vertical asymptote this time. And it's going to be at x equals 0. If you take a look at all their characteristics here between the original versus the inverse, on the inverse, everything just switches position. So my domain and range switch positions, my x and y intercept switch positions, and my asymptote switches position, so from horizontal to vertical. In this next graph here, we're going to do something similar, but this time we're using a function of 1 over 3, so this is a decreasing graph, by the way. So to start us off, we have a coordinate dot at 0, 1, always, always. The next one here at 1, I'm around 1/3, which is probably closer to right there. At -1, and we'd get more decimals if we continue going this way, at -1, we're at +3. And at -2, I'm looking for +9, which is all the way up here. And there we go. I have enough coordinates to try my best to sketch this graph, so here we go. Going right through, and we're going to try to get to that x-axis without crossing it, so there we go. This is my y equals 1/3 x. So I want to draw my inverse, and again, all my inverses are going to be just taking these coordinates and flipping them around. So if my original was 0, 1, now I'm at 1, 0. This coordinate here was 1 and 1/3, so I'm looking for 1/3 and 1. Here we're at -1, 3, so I'm looking for 3. 1, 2, 3, -1. There we go. And over here we're at -2, +9, so I'm looking for +9, -2. Should be right over here. And again, connecting my dots, this is what I'm going to end up with. I'm going to end up with a line following that y-axis right down, connecting through my coordinates, and shooting right on over to this last coordinate. There we go. And again, this here, if I had to label it, this is my x equals 1/3 in brackets y graph. AKA I just inversed it, switched all my x's and y's around. So let's write down our equation. So we have x equals 1/3 y. And again, we really don't want to write our equation this way. Let's use logs to rewrite it. So this is now y equals log base 1/3 of x. There we go. Let's state our characteristics. Domain here on the original is from -infinity to +infinity for sure. Range is as low as 0 going all the way up to +infinity. X-intercept we don't have any, so it's going to be none. Y-intercept we do have 1, it's at 0, 1. And our asymptote is going to be a horizontal asymptote at y equals 0. Over here on the other side, our inverse graph, our domain here is as far as 0 going off to infinity. Our range is going to be from -infinity to +infinity. Over here we don't have any, oh wait, we do have an x-intercept, it's going to be at 1, 0. We don't have any y-intercepts, so we're going to write down none. And last but not least, we have a vertical asymptote that's found at x equals 0. There we go. In this next example here, what we're doing is we're given this coordinate dot here, 1/5 over -1. It's on the logarithmic function, and here's your function, log base c of x, and the point 4k is on the inverse of that function. Determine the value of k. By the way, if it says the inverse of a log, an inverse of a log is an exponential function. So the very first thing I'm going to do, I'm going to take my xy here, sub it into this equation. So I have -1 equals log base c, which I don't know, of x, which is 1/5. From here, I'm going to rewrite it just to find c there. So I have c to the -1 equals 1/5. So I changed it from logs to exponential. Switching this around, I have 1/c equals 1/5. So therefore c has to equal 5. So now I know my base. So I'm going to rewrite my equation. So my equation is y equals c of x, by the way, which I'm filling in. So this is now y equals 5 of x. And if it says that it's the inverse, so I'm going to quickly switch these around. So this is now x equals 5y. Oh no, I didn't need to, I already rewrote it. Sorry, my apologies. I'm just going to solve actually. So we have, let's plug in our variables 4 and k here. So we have k equals 5 exponent 4, and of course k then is equal to whatever 5 exponent 4 is, which should be 625. And there we go. So again, just a reminder, our logarithmic equation is the inverse of an exponential. So if you took your exponential, switched around your x's and y's, and rewrote it back into, you'd have to switch around your x's and y's and then write it in terms of logarithms to make sense of it, out of it. For example 4 here, it says determine the inverse of f of x equals this function here. So again, to figure out my inverse, I'm going to rewrite the equation. I have y equals log base 5 of x plus 2 minus 4. Moving that 4 to the other side, I have y plus 4 now equals log base 5 of x plus 2. And here I'm going to rewrite it, so I have 5 to the y plus 4 equals x plus 2. And from here, so what I've done is rewrite it in terms of logs back into an inverse, and I'm going to inverse this to get it back to almost an exponential. So here I'm going to end up with just going to do it up here, 5 to the x plus 4 equals y plus 2, and get y by itself. So I have y equals 5 to the x plus 4 minus 2 overall. And there we go. This is the inverse of this logarithmic function. Down here it says if f of x equals 8 to the 3x exponent plus 7, in what is its inverse? So again, we're doing more or less the same thing. So right away here, I'm going to rewrite this equation as y equals 8 to the 3x plus 7. And then I'm going to inverse them, so flip these around. So I have x equals 8 to the 3y plus 7. And again, we don't like this format, so what I want to do is rewrite it in terms of logs. So I have x minus 7 equals 8 to the 3y. And now I can write it in logs, so let's do that over here. So this is going to be 3y equals log base 8 of x minus 7. Getting y by itself, dividing everything by 3, so now we have y equals 1/3 log base 8 of x minus 7. There we go.